You know, when we talk about clean energy, our minds pretty much always jump straight to solar panels and slick electric cars. And don't get me wrong, they're amazing, but they can only get us so far down the road. So what if the real key to total decarbonization isn't just about electrifying everything we can see, but about tapping into the power of the most common element in the entire universe? Well, that's exactly where our story kicks off.
And this, right here, is the central problem. It's the big question. Batteries are awesome for your car, maybe even for your house, but what about a 40-ton truck hauling freight coast to coast? Or a massive container ship chugging across the Pacific? Or the kind of insane 1,000-degree heat you need to forge steel? Electrifying that stuff is either wildly impractical or, with the tech we have today, just not possible.
These industries have a name. Experts call them the hard-to-abate sectors, and they are the absolute backbone of our global economy. They also happen to be the toughest, most carbon-heavy challenges we're up against in the fight against climate change. To get them to zero carbon, we need a totally different kind of fuel. And that fuel is hydrogen. But to really get why it's suddenly become this essential missing piece of the energy puzzle, we kind of need to look back at its surprisingly long and fascinating history.
See, hydrogen isn't some new discovery. Way back in the early 20th century, it was the stuff that lifted those giant airships into the sky. Then, fast forward to the 1960s, it was the high-tech fuel that powered the Apollo space program. I mean, not only did it get us to the moon, but its only byproduct was pure, clean drinking water for the astronauts. And even today, most of the hydrogen we make goes into creating ammonia for the fertilizers that, feed the entire planet.
So, here's the crucial point, the thing you really need to remember. It's not the hydrogen itself that's the issue. It's all about how you make it. And the easiest way to wrap your head around this is with a simple color code.
Okay, so right now, most of the world's hydrogen is gray. It's made from natural gas, and the process pumps out a ton of CO2. Then you've got blue hydrogen, which is a step up. It's the same process, but it tries to capture some of that CO2. Still relies on fossil fuels, though. The real game changer, the holy grail, the only truly zero-emission option is green hydrogen. So how do we get this magical green stuff? Well, it's through this beautifully clean and, honestly, elegant process called electrolysis. You take renewable electricity, think solar or wind, and you use it to zap water, H2O, splitting it back into its basic building blocks, hydrogen and oxygen. That's it. No fossil fuels, no carbon emissions. Just clean energy in and clean fuel out.
All right, so now that we've got a handle on what green hydrogen is, let's look at how it actually tackles those impossible problems we started with. We're going to see how it provides some pretty amazing real-world solutions that are already starting to happen.
You'll often hear people call green hydrogen the Swiss Army knife of clean energy, and for good reason. Its versatility is its absolute superpower. It can be a fuel for those big trucks and ships, it can be a source of incredible heat for factories, and, this is a big one, it can be a way to store huge amounts of renewable energy for months at a time. Let's just take steelmaking for a second. It's one of the planet's most carbon-intensive industries, all because it depends on burning tons and tons of coal. But what if you just swapped out that coal for green hydrogen? Well, the whole process gets turned on its head. The only thing that comes out the other end is water vapor. I mean, think about that. We could literally build our future cities and cars with steel that has zero carbon footprint. And this right here might be its most important role of all. We all know the sun doesn't shine 24/7 and the wind doesn't always blow. So what do you do with all that extra solar power you generate on a super sunny day in July? You use it to make hydrogen. You can store that hydrogen in massive underground caverns and then turn it back into electricity months later, say in the middle of a dark, calm winter week. It's basically a massive, season-long battery for our entire grid.
Now, as incredible as all this sounds, we have to be realistic. Green hydrogen isn't some magic bullet that's just going to fix everything overnight. The path to a full-blown hydrogen economy is filled with both unbelievable potential and some very, very real challenges. So let's take a balanced look.
The pros are super clear. Zero emissions when you use it. It packs about 3 times more energy than gasoline for the same weight, and as we've seen, it's just incredibly versatile. But the challenges are just as significant. It's still pretty expensive to make right now, you lose some energy when you convert it back and forth, and it's going to require a massive build-out of brand new infrastructure to move and store it. In this number right here, this is the single biggest hurdle we face today: cost. Right now, green hydrogen is 2 to 3 times more expensive than the dirty, old-school gray hydrogen. That's a huge gap to close. The good news, though,
is that it's closing fast. And that's all thanks to the cost of solar and wind power just plummeting year after year.
And beyond the cost, there are other tricky logistical puzzles to figure out. Moving it around means either compressing it to insane pressures or chilling it down into a liquid at -253 degrees Celsius. We also need rock-solid safety standards to build public trust. And of course, we've got to be smart about where we get the clean water for electrolysis, especially in places that are already struggling with drought.
But even with all those hurdles, the global momentum is it's undeniable. And this is where things get really, really exciting, when we start to look at the applications that are just now starting to pop up over the horizon.
Okay, one of the most urgent new uses is powering the AI boom. I mean, these data centers need a staggering, almost unbelievable amount of electricity, and they need it to be reliable 24/7. Well, green hydrogen is a perfect solution. It can replace those dirty diesel backup generators and provide clean, scalable power that's independent from the grid. It's no wonder that tech giants like Microsoft, Google, and Amazon are already deep into pilot programs.
And the vision gets even bigger. I want you to picture this. Countries that have tons of sun and wind, they could convert all that surplus energy into green ammonia, which is just a form of hydrogen that's way easier to ship. Then they could export it to energy-hungry nations around the globe. We'd be creating an entirely new global trade in clean energy, basically replacing oil tankers with ammonia carriers.
And believe it or not, the vision actually extends beyond Earth. We've confirmed there's water ice hiding in craters on the moon. So the plan, and this is part of NASA's Artemis program, is to mine that ice, use solar power to run electrolysis right there on the lunar surface, and create rocket fuel on site. The moon could become a cosmic gas station, refueling missions on their way to Mars and deeper into the solar system.
So when you step back and look at the whole picture, it's clear. Green hydrogen isn't going to solve every single problem on its own. It's not a silver bullet. But as we've seen, it is that essential missing link. It's the key that can finally unlock the toughest parts of our economy that nothing else can decarbonize.
Which really just leaves us with one final question to think about. Knowing all the challenges, but seeing its absolutely immense potential, from cleaning up our industries to powering the AI revolution and even fueling our journey to the stars, is this simple, powerful element the key we've all been looking for to finally build